These notes are on tree diagrams. Tree diagrams are a way of organizing data according to sort of conditional things happening. So we start off with the branches splitting from a two-option possibility. Patient has TB, patient does not have TB. And then from another two-option possibility that they tested positive, they tested negative, or that they tested positive or tested negative. So we can make a number of statements given this tree diagram. The first one is that we can say a total of 1,000 people were tested. And I get that number from adding 380 plus 620. Another statement I can make is that 380 patients have TB, tuberculosis, which means I could say that 380 out of 1,000, meaning 38% of the people tested have TB. I could say the opposite, which is that 62% do not have TB. That's kind of the basic stuff that I can get by looking at the initial split. And then we have a lot more happening after that initial split. And this line in all of these means given that. So tested positive, given that they do have tuberculosis. Tested negative, given that they do have tuberculosis. So for instance, when we're given when we have the given statement, we would say that 62, I'm going to look right here, 62 patients tested positive for TB out of 620 who did not have TB, which means 10% of the people tested received a false positive, which means these people don't actually have TB, but the initial test came back and said that they did, which now means that these people have to go get further testing to verify whether or not the first test was correct or not. The first test has a level of accuracy that is not as high as perfect, which is often the case when you're getting tested for various diseases and such.